Here we're going to examine the operation of the bit shift left instruction. This is a shift register that shifts in the left direction for a 16-bit word in the PLC's memory. We've specified which word that's going to be. In this case it's binary file number 3, word 0. And we're going to be shifting bits into that 16-bit word one by one every time we get a closure on that virtual contact right there, which is input 00. So I'm using my first input switch to march this shift register over one bit at a time. The bits that are coming into the shift register, that are being pushed into the register, are coming from my input switch number 5, I0/5. And so what I'm going to do is show you how this works by examining the status of this word right here, B3 word 0. So going to my binary 3 file, I open it up, and here I see B3 word 0 right here. Currently all the bits are in the 0 state. If I take my input switch number 0 and I toggle it on and off, back and forth, we don't see any changes happening here because the status of my 5th input bit is also a 0. So every time I energize this input and I cause this bit shift left to go over 1, I'm bringing in a new 0 into that word. And of course, since all the other bits are 0, we don't see any change. Here what I'm going to do though is I'm going to go over to my PLC and I'm going to take my 5th input switch right here and flip it on. Now when I take the 0 input switch over here and go on and off, we'll see a change in the shift register operation. So as I take the input now, input 0, and go on and off, watch what happens. We begin to populate the bits of the 16-bit word with 1s instead of 0s. What we're doing is we're bringing in the 1 state of that input one at a time as I shift those over to the left. So once again, closing this a couple more times, we see this whole series of 1s marching to the left. Now, if I take the 5th input switch and turn it off, I'll go back over here and show you. Take this one and turn it off. Now when I begin to move this input switch number 0 and cause the shift register to move to the left, we'll see 0s being entered into that word from the right-hand side. So here we go. Let's watch. There's a new 0. There's another 0. There's another 0. Notice all the 1s marching over. It's a shift register shifting all these over. Now let's say for some reason I wanted a shift register that was more than 16 bits wide. I wanted to have more than that amount. Well, since each word in this PLC's memory is only 16 bits, I'm going to somehow have to use another bit shift left instruction. So I can show you how to do that. I'm going to close this out. We're going to go into offline mode and do some program changes here. Well, what I'm going to do is take this whole rung, I'm going to copy it, and come down here and paste, and then make some modifications. I want to use the same input bit to toggle the 2 shift registers. Over here though, I want to have a different file number. So this is going to be binary file number 3, word 1 instead of word 0. This is going to be a different control register. Much like sequencer instructions, the bit shift left instruction requires its own control register to organize what's going on. And the bit address for this one, this is the source of the new bits feeding into the shift register every time it's clocked over. I don't want it to come from the same input switch. I want it to come from the last bit, the leftmost bit of my first shifting file. So this is going to be, instead of I:0/5, this is going to be B3:0/15. That's going to be the 15th bit of that word right there that we're shifting the 1s and 0s into from our input. So when those 1s and 0s march all the way over to the 15th bit, they'll now become the input of the next word and begin to shift over again. So I'm going to take this and download this to the PLC. There we go, we're downloading. And it's going to ask me if I want to go to run mode. Yes. And I want to go online. Absolutely. So here we go. I'm going to now bring up my B3 file so we can look at it. Once again, we see B3 word 0 up at the top. Here we see B3 word 1. And just to set things up, I'm going to take my input switch, which is the 5th input switch here, turn it on. I'll take input switch 0 and begin turning it on and off. And we see a bunch of 1s go marching over on that first word. Now just make things more interesting, I'll take the fifth switch and turn it off, and then march this over a couple more bits, and we see some zeros being fed in. There we go, we're shifting over. Now watch, as I keep pulsing this on and off, you're going to see this bit come over here to bit number 15, and notice it appears right over here, because bit 15 is the input feed for my next shift register. So if I keep pulsing, we see this whole sequence of ones leave the top word and enter in the bottom word. So essentially what we have is a much longer shift register. We don't just have 16 bits at the top, we have 16 bits at the top and 16 more at the bottom. Actually, to be truthful, it's 15 at the bottom, because we're taking the last bit here, bit 15, and making it identical to bit 0 of the next word, so we have some duplication there. So instead of 16 bits, we're actually dealing with 31 bits. We now have a 31-bit long shift register by cascading these 2-bit shift left instructions.